Okay, so hello everybody. Thank you for the invitation to be part of this great band of speakers. It's also a great honor to be here for celebrating Martin's retirement. It's always hard to be the last speaker because a lot has been said, but anyway, since I knew I would be the last one, I decided to do a presentation which would be maybe a little bit higher level. So you can see the title, which looks a bit strange because distributed database system is kind of old database topic, but there's also the word new in it. So this is my recent work, I would say, which is with a lean scale company that I will discuss later on, but it's been going very well, very interesting. So let me go directly to the point. So let me start with, well, I guess everybody in the room has read that book already. I mean, the four versions of it, Principles of Distributed Database Systems. So let me repeat some of the old stuff. So this is work with my colleague and friend Tamer Ozu, who is there, by the way. So I'm really happy to see, and many other friends from North America and from South America as well, I've seen. So maybe I'll start with the story of the book, which, well, most of all, it's a long story, and it's the story of a friendship. So with Tamer, so before starting thinking about the book, we first met in 1981. That was at Ohio State University. We were both PhD students. So that was, in fact, that was my first visit in an American university. So that was really great. So a couple of years later, I was working in the US at that time at MCC, where Gerard, by the way, spent a couple of years as well. So in 1986, many of you went to this, especially the old-timers, to the Hawaii International Conference on System Science, which is not the best conference, but it's probably one of the best places in the world because it's in Hawaii. And so we were sitting at the pool at some point, and we decided that we should write a book. So I say, well, why not? You know, and in fact, this was the beginning of a long story. So the first edition was in 1991. Of course, at that time, there were only relational databases and relational database management systems. Interestingly, there's a quote in the preface from Stonebreaker, which at that time already was saying that in the next 10 years, centralized databases would be an antique curiosity. And I guess we would all agree that this is pretty much true. Maybe it took more than 10 years, but this has been really a big thing. So the second edition of the book appeared in 1999. And there were a lot of work on advanced transaction models, multi-version concurrency control, and so on, query optimization, object, database management systems. They were very hot at that time, and then they kind of disappeared. And the big thing was parallel database systems. There were translations in different languages, Spanish, Portuguese. 2011, another edition. So we ended up with new chapters on data replication, database clusters, XML, web data integration, peer-to-peer, and cloud. Which was the big thing. There's a Chinese translation as well. And finally, this year, we came up with the last edition, which, well, we cleaned up a lot of old chapters. So especially the old centralized technologies disappeared. and to make room for new technology. So you have chapters or sections on blockchain, big data, data streaming, graph data analytics, and so on and so on. So to make the link with my presentation, new SQL and polystores as well are really new areas of research and development. And as Gustavo was saying, this is showing the renaissance. I like this word, which has been very important in France, this renaissance of database research. Well, the bottom line, if you look at the evolution, is that we started in the 90s with distributed systems with very few nodes, like maybe 3 nodes, with today's systems with thousands and thousands of nodes on the web, in the cloud, in a cluster, and so on. So I would say the main thing, besides all the variety of applications, is the massive parallelism and the massive distribution that needs to be taken care of. Okay, so let's move a little bit. But before I have another story, this is something that that hits you when you get old. You keep telling stories. So this story is, well, many good things have been said about this famous gentleman that we are honoring today. But let me give you my story with Martin. So our first date, Martin, you remember, was the International Workshop on Database Machines, which was a very famous venue at that time in Tokyo, 1987, where both of us had papers on parallel distributed databases. So as you can see, Martin was already talking about distributed main memory database machine. That was actually a very important project in the world called PrismaDB, which was in the Netherlands with other people like Peter Rappers. While I was working at MCC, there was a Booba project in that company, and this was work with. So forget about declustered databases. This is an old term that Cetrag, my co-author, tried to push. So anyway, we started to meet there. Then later on, I came back to Europe, and then we had many collaborations, actually. So the first one was in a European Declarative System project, a huge project with Siemens, ICL, Bull. In fact, it was strange collaboration because I was part of the project, and Martin was a reviewer. And for those of you who know Martin, he's a tough reviewer, but we got along very well, with technical questions and so on. And then we exchanged places in PhD committees. So for example, I was in the PhD committee of Peter, who is here, who did excellent work on the MoneyDB stuff. We were in program committees, we were in the VLDB endowment, and very recently we collaborated in the context of the Korean PASS European project, where we developed some, in our case, the polystore technology. So it's also a long story. So what impressed me most with Martin is, well, in one word, I would say he's tenacious. And by the way, tenacious was the name of Jim Gray's boat, because he was able to have a consistent research path all the way back from PrismaDB to MoneyDB, which became the pioneering main memory column store. So that's, for me, that's really impressive, because you really need to go into the details, into the implementation. And in fact, I remember once I was visiting CWI, and at some point I was talking to someone. I was coming back to Martin's office. I was asking him, what are you doing? He was saying, well, I'm debugging this part of MoneyDB or whatever. So very good model for system-oriented research, Okay, back to the topic. So maybe a few words about NoSQL very quickly. And this many things have been said before, about the diversity of applications, of systems, and so on. And this is really a good example. You have very different kinds, really based on the data model, with the basic, very simple one, key value, to tabular, big table, etc., document, especially JSON-based as opposed to XML, and graph. And all these NoSQL systems, what we try to do is to trade the relational database management system properties, which have been around for decades, like full SQL, strict schema, SCID transactions, for simplicity for designers. So for example, and if you deal with unstructured data, it's much better, the fact that you have no schema, but also for programmers, because you can really program data-intensive application directly on the database systems using simple APIs. So one major thing that came out of this trend is horizontal scaling. So horizontal scaling is the ability to scale, to deal with bigger workloads by adding more machines in a distributed system, as opposed to vertical scaling, which is trying to do the same thing, but by building bigger machines, which is hard to do and very costly. So horizontal scaling and performance, and also, well, because the scale is so high, you need also to provide high availability techniques like based on replication, failover, and so on. If there's one thing that we can come up out of this, which is in the book chapter, is the architecture is highly distributed. So you have here a sample of a key value store distributed architecture, where you have the two major layers, key value store and data store, so that you can have some independence between the two, and all this can be implemented in a shared nothing cluster with different nodes, and this can scale very, very well. As opposed to, for example, parallel database systems, relational parallel database systems that use a shared disk architecture, which has some bottleneck at some point. Okay, so so now the main point is to zoom on NewSQL. So what is this? Well, if I summarize SQL in the sense of relational database management systems and NoSQL with 5 properties, you will see that they are complementary. So relational database management systems, they are very good at transactions with full consistency. SQL support, this is very important for BI tool vendors, because they have a single, and standardization. Standardization, because it always comes after the fact, of course, so since it's been here for a long time. But horizontal scaling and high availability are not really basic features of, except for the high-end, like Teradata or Oracle Exadata, but these are it can be achieved using very expensive solution and very complex architectures, as opposed to NoSQL, which, well, some of you heard of the CAP theorem, that essentially there was a trading of AC transaction properties for more scaling and more availability. So basically, NoSQL systems don't support very well SCID transactions. They don't provide SQL or something very limited, and of course they are not standard, but they do provide horizontal scaling and high availability. So NewSQL is trying to get the best of these two worlds, and so except this standard, which I put question mark, because since it's new, it cannot be standard, of course. So maybe at some point it will be. But what's interesting is that we start to have quite a number of products around. And these products are really just, they outsource recent research results. So Cloud Spanner is probably the first one that was there to address major applications. So let me say a few words about HTAP that Natasha already mentioned. But this is really a big use case for new SQL. So HTAP, which is kind of a concept from the Gartner group, as the name suggests, tries to blend OLTP and OLAP, which have been done by different systems and different architectures. And the idea is that by blending the two together, you can do analytical queries. I'm referring to Natasha's talk, of course, directly on operational data. And as opposed to moving the data from one system to the other, like a data warehouse or data lake. So the advantages of this approach is, of course, cutting costs of business analytics, but a simpler architecture because you don't need to deal as much with ETLs or ELTs. And there are many important use cases where you need to do real-time analytical queries. So since I'm working with a company, I'm also very interested in real use cases. So let me first illustrate with Google AdWords, which has been implemented with the Google Spanner product. As a matter of fact, Google AdWords was first implemented with MySQL cluster. And at some point, it couldn't scale anymore. It was very hard to improve. And Google decided to, based on the experience with NoSQL, in particular Bigtable, they built a Cloud Spanner, which is a new SQL system. So, so it's an application which brings a lot of money to the company. I just checked the revenue in 2019, which is impressive. So as you know, it's the application for the search engine to provide sponsors links as part of search results. So typically you need to mix search queries, of course, with updates. And what are the updates? The updates are provided by the suppliers because to gain access to consumers or consumer models, which is the probability of responding to the ad, suppliers need to pay and they need to determine the right price offer. So basically they have an interface and a tool with which they keep updating their so-called maximum cost per click bid. I'm not sure these numbers are accurate this couple of years ago, but this is really big. It's a really big database, of course, because it's a big company. And here's a use case that we are dealing with Linscale. It's IT monitoring. So in IT monitoring, there's a process of gathering metrics about the whole IT activity of the company or a bunch of companies to ensure everything functions or will function as expected. So it requires monitoring many systems, applications, and metrics at very high frequencies. So the data management requirements are very high. You need to compute real-time KPIs to detect, for example, root cause problems or analyze incidences, or combine historical and current data for doing analytical queries like drill down, forecasting, and reporting. So what's needed and what's been done with Linscale is to do fast data ingestion as with a NoSQL system and analytical processing as with SQL. So let me say a few words about the techniques now. So you could say, well, if you want to build a new SQL, since it's a blending of SQL and NoSQL, well, let's just put all the techniques together and it will work. It's partly true. So for example, from SQL, you can get data analytics techniques. The query optimization is a big one. Parallel in-memory query processing, column store techniques, which are also part of NoSQL, by the way. From NoSQL, all the key value storage and access, which is very efficient, the horizontal and vertical partitioning, and all the availability techniques, fault tolerance, failover, synchronous replications, and so on. So what I think is really new is to be able to do scalable transaction management, because if you think of traditional SQL systems, well, they scale because they use a shared disk architecture, but they don't really handle huge workloads like the previous one, Google AdWords. And also, and this is related to the previous talks about the diversity of systems and so on, you have to assume that you need to access many different kinds of systems. So polystores are reminiscent of federated database systems to access SQL, NoSQL, HDFS data stores. So let me illustrate with solutions to these two techniques, techniques in Linscale. Linscale is another friendship story, because the company has been founded by Ricardo Jimenez Peris, who used to be a professor at University of Madrid. Ricardo's been very famous. Many of you know him. He's been working on transaction management, replication, snapshot isolation, among the famous SIG-mode or VLDB papers or whatever. So he's a good friend. We are very complementary because my background is more on query processing. So we've been working together. The company is now 5 years old, and it has 20 people. It's a great company with top level engineers. I'm really impressed. And it's pretty sound. So just a summary of the features. So it provides SQL, database management systems, but the language is polyglot in the sense that it has JSON support. It is implemented based on a relational key value store, which provides the best of relational and key value storage. The first version was based on HBase, but it was not as efficient as it could be. So this is what provides fast parallel data ingestion, but also there are a lot of good ideas to do online aggregation using aggregation tables. Aggregation tables is really a great idea, because when you do analytics, you need to do aggregation. And because in Linscale, the updates and the transactions are very, very efficient, they are really ultra scalable. Aggregation tables are basically tables that updates the data that you need in the aggregation. There's an OLAP query engine, which supports parallelism, of course, and polystore access. And I will say a few words about transaction processing. So one interesting thing, and this relates a little bit to the discussion before with Gustavo's architecture, is that it's really a clever architecture, because the different functional engines, like the key value store, the transaction engine, the query engine, and the OLAP application, well, the three basic engines, they can be scaled out using horizontal scaling independently. And this is really a great way of doing things. There is a very successful story called Snowflake in California, which is a data warehouse in the cloud, and they use a similar concept. And by the way, Snowflake has been one of the CEO is Benoit Dacheville, who did his PhD with me a long time ago. So one thing that we do, and this is really very interesting, is parallel polystore query processing. So most polystore systems, at some point when they join, for example, data from MongoDB and from a relational data store, they will do it in a centralized way, while we can do it in parallel by exploiting data sharding. So there are a couple of papers about this. There's a SIG-mode paper describing the cloud MDSQL polystore system, which we built together. And there was a more recent paper on this ability to do this. This is very interesting, because you can, because of the architecture, we can capitalize on this architecture to exploit parallelism. And a major innovation is scalable transaction processing. this is kind of odd because it's a very old topic. It was in the first edition of the book with Tamer. And so I was amazed that there was still a lot of work to be done. So this is has been published only in a patent for proprietary reasons. So in the traditional transaction processing approach, even though you use a parallel system, at some point there will be a bottleneck because there needs to be some centralized coordination. Think of two-phase commit or 2PL or whatever. And so basically it will hurt. Although the execution is done in parallel, this coordination will become a bottleneck. In lean scale, for the people in Brazil, they should recognize this. These are not the falls of the Niagara Falls. These are the falls of Iguazu, the south of Brazil, which are really my favorite, but I'm biased. So the idea here is that you can process and commit transaction in parallel as long as the system is able to provide a consistent view. So how this is done? Well, this is done by scanning ACID properties independently with, for example, atomicity with local transaction managers. It's based on snapshot isolation, so there is no problem with conflict between reads and writes. So there are only conflict managers for the writes. For the reads, it's based on snapshot isolation. So you have snapshot server, which provides timestamps, and basically a commit sequencer, which makes sure everything is viewed in the right order. And also there is durability. So the principles are very interesting. The separation of commit from visibility of committed data. There is also pre-assignment of commit timestamp to committing transaction. All the conflicts are detected before the commit. And because of that, the transaction can commit in parallel. So there is no bottleneck. So that's all I'm saying, because the story is much longer and I don't want to go into the details. So let me go to the conclusion because it's about time. So the main takeaways, well, I think the distributed database systems, they really pass the test of time, right? Because I've been there for 30 years. And centralized database systems really are an antique curiosity. And that's very interesting related to Gustavo's presentation. When I first started working on database machines, the hardware people, they were saying that, well, you should not do distributed databases to do scaling or whatever. We'll do, all the parallelism will be done in the hardware. And clearly, you can do that, and Gustavo showed that, but you also need to have to scale out. And what has been nice is I think we have clean principles. So they are really the basis for many variations, but also to understand and to teach students and so on. So I hope this is useful. Now, is new SQL the future of SQL? Yes, I'm spending my time on it. So I really think HTAP is becoming a major workload. There are many reasons. You have sensors everywhere and so on, and you want to make decisions in real time. I'm referring to Natasha's talk. And there are still many research opportunities, although it's also industry oriented. For example, Polystore, streaming, machine learning, of course, benchmarking, and also exploiting all the new hardwares, which is what we are doing. For example, FPGAs and TPUs are very, very important. Okay, since I'm last, I'm having the final word. This is the advantage of being last. So I just want to thank Martin for all he has done for us as a research community, but this has been said. Of course, I wish him happy retirement. So what do I wish Martin? Well, initially I thought about this, you know, going to the beach and lay down. And then I thought, well, but Martin is a very active person, so maybe he will get bored very quickly, and he has so much energy, he cannot waste his energy like this. So I'm also wishing Martin an active retirement, and that would be the end.
Thanks so much, Patrick. Yes, that was a very nice talk. You actually mentioned Snowflake. Yeah, they IPO'd for $70 billion valuation, which was incredible, by your student Benoit Dagpil.
Yeah.
One of the other founders is Marcin Ostrikowski, my first PhD student, and who graduated, a graduate of Martin Kersten, in fact.
And Benoit, by the way, was part of the first project I mentioned, the European Declarative System project.
Right. So
yeah,
let me click on this gallery to see if there is a question from the room.
I see there are lots of comments, but they are still talking about how why Mohan is making.
Mohan is asking money questions now.
Yeah.
Zero. Let me see. Where's the?
Yeah, Mohan has this question. Well, you know how many billion did the advisor get with the Snowflake APU? Well, no, well, at least my recognition is that if you go to Benoit's Wikipedia page, he refers to me as PhD advisor. So that would be it.
Okay, but what question? I mean, it was interesting talk. So you're trying to and also work on new SQL, basically working on HTAP systems in the lean scale system. Yes. I hope that eventually you will publish not only patents but also scientific paper on the secret sauce on how to make HTAP scale horizontally, because that is non-trivial.
So there is a blog. So we are writing kind of white papers right now with Ricardo. So this will explain the technology. But what would be better is if we could have research papers on some part of the technology. But as you know, in a company like this, it takes time especially to do experimentation and so on. So the experimentation really comes the hard way with real customers.
Right. Okay. Yeah, Mohan he says that DB2 event store has done HTAP and is a product. Mm-hmm.
In fact, this is interesting point by Mohan, but even if you think of Oracle, because they do multi-version concurrency control and so on, and they have claimed for a long time that on the same database you could mix OLAP and OLTP workloads. And I've worked with customers, and it's not possible, So basically, people they will use one version for LTP, one version for OLAP, but they will not mix because. So I'm not sure how DB2 Event Store does this, but.
Well, yes, I'm also intrigued, also with regard to lean scale, because there are just clashing concerns for achieving high updates and well, for instance, indexing and clustering that you would want to do in order to do fast analytics. So yeah, that's indeed a hard topic. However, in the interest of time, I would like, Stefan, can you maybe put back the program slides on the full screen? Yeah, thank you. So thanks again, Patrick, for this very nice talk.